Okay, so, and the linear function, very simple. We just go that's going up, that's going down, and we'll go flat. Now, in the real world, things are not that simple. Real world, we deal with something called nonlinear function. One example is temperature. Does temperature always go up?
Pardon?
Does temperature always go up?
It can.
It can. How about over a
But
year?
over a
Now, if over a year, how the temperature goes?
Uh, there are many different causes, but I guess you could say global warming.
Well, unfortunately, there is no really much evidence to support global warming, um,
Yeah.
uh, because the tricky part is a lot of people confuse not linear function with a linear function. Many people make
Hmm.
predictions based on linear function. Like say between say 2020 or 2000 to 2020. Now, if we do see that average temperature go up like this, now what should we expect? Should we expect to keep going like that?
No.
We don't know. It might become something called cyclical. That means they are going up and down over a certain period of time. Okay, this is called cyclical. And this is pretty much in a way our temperature goes year over year. If you look a long time and we got say, well, just think of last year and to now, what's our temperature going? Well, pretty slow, right? This is January and this is summer. So something go like that. Well, especially in Indiana, we could have something go like this, right? So we're going up and then we're going to go down, right? Okay. So this is a so-called nonlinear function. If we're looking at over, say, over 10 years, 2014, over that, so we're probably going to see something like that, right?
Hmm.
Good. That's why we have seasons, right? We got spring and fall and what. Now there are some places uh, they don't change as much. If you go to like San Diego, their temperature they don't really have four seasons, so the change is not that much. Or if you go some countries, they just have two, either like rain all the time or hot all the time. But no matter what, it's year over year is cyclical, repeat. We also talk about something go viral. Now, something go viral is when you have a virus, normally it start pretty slowly, but all of a sudden it took off, go like that. Good. Well, in the real world, so if you want to make prediction based on, really depends on how you make prediction. If you want to make prediction based on just very short period of time, you probably see something like this. Expect that. But if it's go viral, it just take off pretty fast. And if you say, okay, now maybe we can make a prediction, it will go like this. Well, in reality, it won't go like that. it will go actually certain points going to go down like that. Okay. So let's say this is the virus affecting people, how the virus spread. Now, why we have something go like this? Why will it taper out?
Because it can no longer expand.
Could you
Could you
most
most
Sorry, what?
could you make
could
it
you make it
more
more
A mole?
more?
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 Yeah.
Your
Statement is too
statement is too
general.
general.
Sorry, I think the call's breaking up. What's that you said?
Your statement is too general.
Oh. What I was trying to say was eventually it'll reach a point where it can no longer expand, where it's reached
Why is that?
potential.
Why is that?
Because eventually there'll be no more people to infect, I guess.
Yeah, exactly. We have a limited number of people, so eventually will taper out. And that also tell us two things. One is that we can use functions to make prediction. At least it's educated guess. It's not just like randomly pick something. But also when we make predictions, we also have to be careful. That's something we call model. People talking about model basically is to build a function. Now, their function can be very, very complicated, but still just making functions. And based on functions, they make predictions. And so that's why we got to be careful. And we don't know what happen in the future, but we need to understand based on what we know. If we just simply based on what we know, then our prediction could be way off. And this is a problem with global warming because the data they got, we don't have that much data. So if we just based on the past 20 or 30 years, and it's just not enough. Because things could go either way. It could be going linear, it could be going like viral, or you actually can just taper it out and just, or sometimes go down. And that's the thing. And one thing we know about the climate, we know that the Earth has experienced cooling and warming in the past, and there is not enough people there, so people might not be the problem. There could be some force of nature that it doesn't really matter how many people or how many CO2 in the air. There is some force of nature that doing that. Yeah, but unfortunately now people using global warming. Well, they don't talk about global warming anymore. They talk about just climate change, and so they can they can have both ways that way. In the 70s, they talk about global cooling, but that didn't happen. And then we talk about global warming, and that's not really happening. So now they talk about climate change. The goal is the same, is to have more control. So basically, because they want to save the planet Earth, so therefore you have to give them, the control about how you live your life. So that's the way you say, okay, you had to buy like electric cars, you have to, you know, uh, uh, you shouldn't own cars. You should just like go to the public transportation, and people shouldn't have a big houses, things like that. Okay, so those are nonlinear functions, and the simplest nonlinear function is called quadratic function. That's why we're going to spend some time learning. And the rest of the semester is about functions, all kinds of nonlinear functions. Okay.
On.
the quadratic function. And it has a square term. For example, one would be x squared plus 3x plus 5. Now, if we only have this part, this is the linear function part. Once we have a x squared, then what we got here is a quadratic function. Now, quadratic function has, when you're graphing it, actually is a parabola. And we could have either go this way or we go down like this way. So, and it could be more flat or could be more narrow, but they are quadratics. So they have the property that it has a vertex point. So this is the lowest point, this is the highest point. That's called vertex point. And if you draw a vertical line across that, then this half and that half are symmetrical. So basically, you can fold this half along the line, they call the line of axis of symmetry. Then you got a perfect, this will fold on top of that, perfect line up. Good?
Mhm.
Okay, and the problem has a lot of real life applications. One of that is the satellite antenna. You guys probably have seen the satellite dish, right?
Mhm. Yep.
Okay. So that using the property that every parabola has a focus point. So when the electromagnetic wave, which is a radio wave, comes in, they will get converged on this point. And so normally they have a receiver right here. I don't know if you have seen it. You have kind of sticking out over the curve.
Yes.
And they also use that for what do they call that? Like when you're trying to search airplanes in the dark. What's that called?
Radar.
Not radar, the light. You want searchlight?
Yeah.
Yeah. So they actually put
Spotlight.
spotlight.
Yeah. Spotlight. Yeah. It's welcome.
So they basically put the light source in the focus point. So the light, when they come down, they all go out in a straight line, go like that.
Yeah. Spotlight too.
Good?
Yeah.
Yeah, so that's why they can do that to search airplanes in the past, when during the Second World War. Yeah, you probably have seen the movie, right? They turned on, they kind of like a big cylinder of light, and they pretty strong, so they can do that. Okay, so now normally we write this as y equals to ax squared plus bx plus c. Okay, so this is a coefficient. This is also coefficient before that, and this is a constant. And one thing about this one, this whether or not this is positive or negative tells us either we go this way, it's called concave up, it point to the up, or go that way, concave down. So this is when A is positive, and this is when A is negative. So depends on that, we can either up and down, and something up, this vertex point, we call this is the minimum point, because at this point, y is smallest, but minimum. And on here, vertex, we call that maximum. Now, in real life, a lot of times, like it doesn't mean that if you spend more money, you get more return. Sometimes there gets to a certain point, the more money you put in there does not really increase, you know, whatever the return you get. Have you guys heard the term diminished return?
Yes.
Yeah, I believe so.
Okay, what does it mean? Diminishing return.
That means when you put so much in that you don't have any more to put in, so your return slowly lessens over time.
Yeah, it just means that the more you, let's say, more money put in, doesn't mean you'll make more profit, or there's more effort put in doesn't make it the things what you're doing even much better. It's just like, have you heard something called 2080 principle?
Sorry. What's that you said?
2080 principle.
2080 principle? Yeah, maybe.
Okay, so this actually, which means that if you're doing something, 20% of your effort, you'll finish 80% of the task. This is your task, this is your effort, or the time. Okay? And then you spend 80% the effort for only 20% of the task. Have you heard that?
No, I haven't.
No.
Well, think about the things you're doing. Doesn't matter what you are doing. That means it is not linear. It doesn't mean the more time you put in there, we got the equally mean we'll have say well, let's say do you guys do any project?
Yeah, I'm building a model.
Yeah.
Okay, I know Jed is building a model. Okay, say Jed, if you're building a model, you can get most of it done in a pretty short time, right?
Depends how detailed you want it to be.
Well, let's think. You can pretty relatively short time make something kind of roughly okay.
Yeah.
But if you want to make that kind of a good quality, then that means you're going to spend a lot more time on that, right?
Yeah, a lot more research as well.
Yeah, and so that's kind of 20-80 principle. And we see what any of you doing something project at home or
Yes and no.
okay?
Uh,
How do you do it, Asher?
so I mean, I don't do that much anymore, but I'm in 4-H, and every year I sometimes do a project on a certain program I'm in. So,
Could you give me an example? What kind of things?
so I think last project I did was on fur bear trapping. It was how to set a certain specific trap for a coyote, I believe.
Okay, okay. Now, it won't take you that long to basically have some kind of
Mhm.
overall, right? Overall
Hmm.
structure or frame.
Yep.
Okay, but it's going to take a lot of time to, you know, to get those details
Mhm.
hammered out, right?
Yes, sir.
Yeah. Anyone do any painting or drawing?
I do, yeah.
Well, you pretty much can have the overall thing work that, right? But
Yep.
then you spend a lot more time just to fill in the details to get looks to your satisfaction. So that's basically what that means 20/80 principle is that you spend 20% of time to get 80% of task done. Then you spend 80% of time to get 20% effort done. So you can see that this is not a linear relationship. Good. And when you do project management, you don't based on the linear assumption. You basically say, okay, well, maybe I got a lot of done in a week, but I do not expect that I can, finish the rest in say 3 weeks or 4 weeks. We might spend more time than that. So that's kind of linear, non-linear kind of relationship. Now, have any of you did any type of project management?
Like what kind of projects?
Well, normally it took you like many weeks.
Yeah, yeah.
Oh, yeah.
Like, do you make sure everything on track and you got those time allocated for it and something got done by certain time so that you won't be behind schedule, things like that?
Yes,
Mhm.
yes.
So if you do that, you can see that a lot of times it's non-linear. You cannot say, most time it's based on your experience. And I normally will allocate more time towards the end to make sure we got things done. So that's why nonlinear functions are important in our life. And that's one of the reasons that we study nonlinear functions. And that give us the idea, when we're looking at things, we know it's not only we know it's nonlinear, but we roughly can know what kind nonlinear function that it would be look like. We won't get exact, but you could say, okay, should I get something like a quadratic function like this? Or should I get something more like this? Or something actually go like this? Or something go like this? Good?
Yep.
Yeah. And well, you're also going to learn something in this matter, a function called rational function, which actually look like something like that. It's actually broken. Okay, so we have different kind of functions that we're going to learn. All right. Yeah, make sure you finish the homework. I need to give you also homework for point slope. And then next week, we're going to focus on quadratic functions. Okay,
All right.
Okay.
Sounds good.
bye.
Hey,
Bye. Yes, thank
Have
you.
a good day.
Yeah, you too. Bye.
Bye.